Good morning, afternoon, evening, Ms. Hanisa and Mrs. Christine as our lecturer research methodology in computer science. Now we'd like to present you about our paper with the title Research Using Backpropagation Algorithm, Predictions of Duck Egg Production in 34 Provinces in Indonesia. Next. So you can scan this barcode QR code to see about full version of our paper. And then this is about our team. There is Alvin Wijaya as my partner, Jonathan Andrea as myself, Nicholas Jackson, Mrs. Kristen Margis running room, and Miss Hanisa Melesa Putri. About the contents of our paper is introduction, literature review, proposed methodology, research and analysis, and then with last conclusions. So we're talking about introduction. Our research paper discusses how the backpropagation algorithm works in predicting the productivity of duck eggs produced in 34 provinces across Indonesia. As we know, duck eggs have much benefit contents. The goal of our research is to assist duck egg farmers in 34 provinces of Indonesia and estimating the production so they can expect from their ducks in coming year. With these results, the egg farmers can increase their productivity. Next, about the literature review. Based on our previous research and research paper or journal, we have obtained several insights that will help our research. Among them, several backpropagation methods are an algorithm that can produce accuracy numbers that are quite high compared to algorithms commonly used to predict an event, such as radial basic function or RBF, long short-term memory LSTM, and then cyclical order weight or bias. Although the dataset and research conducted have never used the egg data, so we will prove whether the accuracy and prediction values that will be generated in the following year are effective or not. So about the proposed methodology will be continue with my partner. Thank you.
Okay, now we go to proposed methodology. Next. Search flow of prediction duck eggs. Through various data processing steps, we begin with searching for data and end with obtaining predictive value that align with future expectation. Look at this. We start with input dataset. After that, we go to pre-processing dataset and split the dataset collection to data training and data testing. After that, we normalization the data. We select network architecture and the end, we predict the result. Next. Methodology of algorithm. Data selection. In this step, we use the dataset from the Central Agency of Statistics of duck egg production in 34 provinces with a time range of 2011 and 2022. To minimize the data, we just show 6 provinces data from 2011 until 2022. The detail of the data selection is shown on table 1. Data pre-processing. In this stage, we perform data cleaning by removing incomplete or invalid data and preparing the data to be processed by the backpropagation algorithm. We choose the range of year 2011 until 2020 as a data training and 2021 as the result of data training. Then year 20 and 12 until 20 and 21 as a data testing on table 2. And 2022 as the result of data testing on table 3. Next. Table 1 data selection. We count from 2011 until 2022. Next. This is a table from data training from 2011 until 2020 and the result. Next. This is a table from data testing from 2012 until 2021, and this is the result. Next, this is formula for normalization. We need a result of normalization data that will be normalized, the lowest data, and the highest data from the data set. And my friend will next.
Okay, move on to result and analysis. Uh, based on the data we collected, it was divided into two parts: training data and testing data. That has been normalized. What my partner said on the methods. The details of this data will be provided in table 4 and table 5. We can take a look on the table 4, normalization of data training. It has normalized data that shows us on 2011 until 2020 and the result of the 34 provinces in Indonesia. On the table 5, normalization of data testing, similar to the table 4 that use the year of 2012 until the 2021. On the table 6, data training with models 10, 20, and 1, which is the best model that gives us the best accuracy besides the other models. It shows us the target output, error, SSE, and the mean of the SSE for training data. On the table 7, similar to table 6, but it's for testing data and includes the results that represent error tolerance. In this case, the error value that can be tolerated is less than or equal to 0.001, which is assigned a value of 1. The result will be used for calculating the accuracy of the prediction. Comparing all the models, we use 5 models. That's 5, 10, 15, 20, and 25. On the table 8, comparing all models of architecture. It shows us the MSE training, MSE testing, and accuracy from all 5 models. On the table 9, details of data testing model architecture shows us models, epoch, or the iteration, the time that the model needs to calculate the data, MSE testing, and accuracy. This is the formula for the prediction values. It needs the result of prediction, target of prediction, minimum data of data set, maximum data of data set. On the table 10, this is the result of predicted egg production in 2021, 2020, 2022, 2023. For the conclusion, using the 1021 architecture model, the accuracy obtained is 91% with a margin of error 9% obtained by 100% minus the calculated accuracy value. After determining the architecture models that has the highest accuracy value, it can be determined by looking for the predicted value in the following year using the same method and architecture model that we use on 2023. Of course, these numbers can change with interval and external factors. And also our predictions still have a margin of our value of 9%. These are the references that we use for the conference paper. Okay, so that's quotes from Manus Aurora. Be like a duck, paddling and walking very hard inside the water, but everyone sees a smiling and calm face. That's all from us. Thank you for listening.